Problem 37. Describe the preparation of 2 liters of 0.25 molar formated buffer, pH 4.5, starting from 1 molar formic acid and a solid sodium formate, and gives the pKa of formic acid. Okay, so 2 liters, 0.24 molar formated buffer. pH desired is 4.5, and start from 1 molar formic acid. So this is going to be a formic acid and a sodium formate buffer, right? An acid and a conjugate base being formate, and the pKa was given as 3.75. So we have the formic acid HCOOH, and it's going to be in equilibrium with H plus and the HCOO minus. That's the equilibrium for formate acid, the dissociation of formate acid. We now know that we are dealing with a problem of a buffer, so first thing is write the equation so that you get the things right for the Henderson-Hausenberg equation, right? So is that a pH in here because we are dealing with an acid. Then we are going to have the conjugate base as the numerator and the acid as the denominator in the Henderson-Hausenberg equation. Let's write it down. pH equal pKa was given also, plus logarithm of the concentration of HCOO minus. That's why it's important to write the equilibrium reaction so you don't make the mistake. HCOOH formic acid, non-dissociated formic acid. We have 4.5, that's the desired pH. We have pKa that was given. How much was that? 3.75. Okay, it was given 3.75 in the problem. So let's write down here what was given. pKa equal 3.75. All right, so plug in to 3.75 here, plus log of the concentration of formate over the concentration of formic acid. With that, we are going to be able to calculate the ratio of formate to formic acid. Let's keep working on this. All right, so the difference between now we're going to put the like terms on the same side of the equation. 4.5 minus 3.75. In the interest of time in here, let's do already the result, which is 0.75 equals log of concentration of formate of formic acid. From here, we can take, based on the anti-log, we can say that the concentration of formate of the concentration of formic acid is going to be 10 to the power of positive 0.75, right? Because the difference was positive there, 0.75. Yes, 0.75. So you plug in this number in the calculator and you get this 5.62 for this, 5.62. So now we can write the two equations that we have. One is that the HCOO minus equals 5.6.2 concentration of formic acid. We need another equation. You have one, because we know that the sum of the concentration of formate and the formic acid is equal to the concentration of the buffer. Okay, formate plus formic acid equals the concentration of the buffer, and the concentration of the buffer was given 0.25 molar. So 0.25. Now we have two equations, two unknown. We can solve that. Again, this is the buffer concentration as was given in the problem. So now we go in the replace things in here. Instead of HCO minus, let's put 5.6.2 concentration of formate in here. Okay, 5.62 concentration of formic acid plus concentration of formic acid again equals 0.25 based on the last equation. So now we have 6.62, right, altogether. 6.62 concentration of formic acid equals 0.25. So therefore we have the first solution here. That's going to be the solution for the concentration of formate in that buffer. And the concentration of formate is going to be (0.25) divided by 6.62 gives 0.038 molar. 0.038 molar. And you want to make it 2 liters of this buffer, right? That's what he's asking, 2 liters, yes. 2 liters of this buffer. So, okay, so this was the concentration of formate. From there we can, the formic acid, then we can concentrate formate as well. But let's first calculate the amount of formic acid that you need for that. We are starting with a solution that's 1 molar formic acid, right? And we're going to add 1 molar, and we're going to dilute to make 0.038 molar, 2 liters, right? So that's a problem of dilution here. So the volume of formic acid from the concentrate solution that I need to put to make this buffer is going to be V1 equal 0.076 liters, or in another word, 76 milliliters of 1 molar formic acid. So I'm done with the first part. I know how much formic acid I need. Let's calculate the formate. Let's change the move the page in here and rewrite this thing. For formic acid, we take 76 milliliters of the 1 molar solution that was provided. These are very real problems in the lab, you know, that we deal with what we have in the lab, what's available. So we had a 1 molar formic acid. We take 76 milliliters. Now let's calculate the concentration of formate. From the equation before, the page before, we had the HCOO minus equals 5.62 concentration of formic acid. That was derived from the Henderson-Hausenberg equation. Now, we know that the concentration of formate is going to be then 5.62 times the concentration of formic acid that we just calculated was 0.038. So we need 0.213 molar of formate to 13 molar of formate to make it this. But formate was given as a solid. Sodium formate is a solid. So we have molarity is mass divided by molecular weight and volume in liter. Do we have the molarity? Yes, we have the molarity. What we need to know is what's the volume we need is 2 liters. Now we need to know what mass we can weight of this sodium acetate. Sodium acetate, HCOO minus Na is a salt. And the molecular weight of this is very easy to calculate, right? 68. So now we can calculate the mass. The mass is going to be equal to the molarity times the molecular weight times the volume. The volume is 2 liters that we need to prepare. So we're going to plug all these numbers here. 0.213 is the concentration, 68 is the molecular weight, and 2 is the volume. So we need 28.9 grams of sodium formate. So you put 28.9 grams of sodium formate, you put a certain volume of water, put 28.9 grams of sodium formate, then you add 76 milliliters of formic acid, and finally you complete the volume for 2 liters. And that's going to give you the buffer that you want. So here are the two numbers that you need to know and put together and complete the volume for 2 liters, and you are done with that buffer.